water trough is 10 meters long. So this is 10 meters long like this. 10 meters. And cross section of a shape of an isosceles trapezoid that is 30 centimeters wide at the bottom and 80 centimeters at the top here. And height of 50. So the perpendicular height here is 50. If the trough is being filled at the rate of, so dV over dt is 0.2 meter cube per minute. Note that this is given in meters and these are given in centimeters. How fast is the water level rising? So we're looking for dH over dt. So let's draw an example of water being filled in. Okay. So it will look something like this. Okay, so the volume of this water here, actually maybe keep it blue, is going to be the area of the trapezoid, which is dependent on the 30. And let's call this width here. From here to here, let's call it width. So 30 plus width, and times by the height, which is also varying, times by half, and then times by the depth, right, which is also fixed. And that's given to be 10, so that's in meter, 10 meters, so 10 meters. So let's times that by 100 centimeters. Actually, this is in meters, so let's convert all the centimeters actually into meters. So this is going to be 0.3, this is 10, this is 10, the 10 meters stays the same, and 30 plus width, height 10. Okay, so this is the volume. Okay, and we want to find dH over dt. So let's differentiate with respect to time. So if you multiply those two, you actually get 5. So dV over dt is equal to 5. I'm going to do product rule, differentiate this, and we get dW over dt times by h, and then 0.3 plus W dH over dt. Okay. And we're given that h, we want to find dH, right? dH over dt when h is equal to 30. Okay. 30 centimeters, so it's 0.3 meters. Now, let's just draw this trapezoid in the front. Okay, for to look at directly on, it will look like this. So this is 30, and there's a water level here. This is 80, and this is our W. So the question is, what is the relationship between W and H? Right, W and H. Actually, let's exaggerate this a little bit. Like that. Make it. Okay, let me exaggerate this a bit. Okay, so this is the same length. I'm gonna do this. Okay. And of course, we have our W like this. So this whole thing is W. So let's call this. So if this is 80 and this is 30, if you take the difference, it's 50. So this is 25. So it's a similar triangle we have to compare. If this whole thing is W and this is also 30, this right here must be W minus 30 divided by 2. So that right there is W minus 30 divided by 2. Okay, that's that. And we know that this divided by the height, this is the height, right? So W minus 30 over 2 to the ratio of H must equal to 25, right? And the height here was given to be, height was given to be 50. So this whole thing was 50. So that must be the same ratio as 25 over 50. Okay, which is 1 to 2. So this is where we're going to get the relationship between W and H. Okay, so we can multiply, so this is W minus 30 over 2 times by half, right? Divide by H is the same thing as times by half. Okay, you can multiply both sides by 2 to get W minus 30 over H is equal to 1. So W minus 30 is equal to H. Okay, so we're given that H is equal to 0.3, right? Or 30 actually. W is going to be 30 plus 30, 60 centimeters. So this is going to be 0.6 meters. Okay, so we can now plug it in. W to be 0.3 plus 0.6, that's 0.9. We're looking for dH over dt. Note that from here, if I differentiate both sides with respect to t, dW over dt and dH over dt is equal. Okay, so this is also dH over dt, and H I can replace it with 0.3. And dV over dt was given to 0.2. Okay, so this is 1 over 5, so it's 1 over 25 now. And when you divide both sides by 5, 0.3 plus 0.9 is 1.2 dH over dt. This is 1.2 is 12 over 10, which is 6 over 5, right? 6 over 5. So dH over dt is going to be, if you multiply both sides by 5, you get 1 over 5. So dH over dt is going to be 1 over 30, right? 1 over 30. So this is, the unit was in meters, right? Meters per minute.